Okay, so I think the only missing piece right now is like the full picture, how you get your input and how the model is being trained like every epoch. So let's quickly go over that, and then we'll take questions. So you define your network, all right? So this net was the class in Python, and that's how you instantiate different objects. Okay, so then this is your network. And of course, you can instantiate like this class multiple times. That's the beauty of class in Python or in any programming language. You can have net, or you can have another network here using the same class. So you can have multiple networks of similar type. Then you define your data loader. This we briefly go over before. So you'll have to pass your training set. We'll have to define like what's the batch size. Shuffle will be true for training and how many workers you have. Okay, so that's your training loader. And this loader is actually going to give you batches of your data. So you define your loss function. In this case, it's saying cross entropy loss, which is fine. If you're doing classification, then you will use cross entropy loss. And this is defining optimizer, SGD. Okay. In this case, we are also passing value for momentum. If you don't pass, then the default value will be used. I think the default value is actually, I think, 0.9 for SGD. Okay, so this is the actual network training. You will decide like how long you want to train your network. Let's say you want to train for 2 epochs, which means that your network will see every sample of your training set twice. All right. So then this loop will be run like twice, and in each loop we are going to watch, your network is going to watch all the samples once. Okay, so this is just you are maintaining some loss value, and the inner for loop is actually going over your training data once. So this is the train loader which we defined earlier. When you iterate over this train loader, it's going to give you batches of your images. Okay, so I is just like a index, right, which enumerate will give. You should know that from Python. And data is your batch of images which this train loader is going to return. Okay, so in this case, exactly, if you will have to compute like the shape of this data, this is going to be 4 times 1 times 6, 28 times 28. Considering your batch size is 4, and you have a grayscale image of shape 28 cross 28. Okay, so that's your batch. And after this, you just take this data and pass it to the network. And so this loop is actually doing one iteration of your training, which will include like feed forward pass and backward pass, which will include like computing gradients and updating the weights. And you just repeat this for loop. Okay, so data, you will have inputs and labels. Oh, sorry, I missed the labels. So this input is your batch of image, but of course you need the ground truth as well, right? Which is like for each image, what is the ground truth to actually compute the loss. So that's actually all is packed in this data variable. So which is fine. Then you zero the gradients. Okay, then your forward step, backward step, and then you finally optimize. So this is the forward step. You pass that input to net, get the outputs. This is you compute the loss function. And this is the backward step where you compute the gradients. And this is the optimizer where you change the values of your network parameters. So that's like one step of network training. So that's it. Okay, and these are like just logistics. I mean, if you want to monitor your loss, like how your loss is increasing, decreasing. But again, this is just some plain Python code. This is just bookkeeping. We don't have to worry about this. Okay, we skip that. And eventually, once your network is trained, what you want to do is you want to save your network weights, right? So it's like for each trainable parameter, you will have to save it. And that's a simple function, torch.save, which will save this state dictionary. So it's a dictionary because you have name for your layers, and then you will have name for every kernel in your layers, right? And then those will have some learned weights. So you have that dictionary. So you can, in fact, like just try to print these network prints just for fun. Just try once, like printing this dictionary. It will give you like exactly all the parameters you have in your network and their corresponding values. Okay, so that's training, and testing is similar. The only difference is you only do feed forward step to get the predictions. You don't worry about computing gradients and updating the network weights. So we've defined test data loader earlier. So similarly, you are iterating over your testing samples. And so again, this is like you can select iter, right? So each time you do next, it's going to give you your batches, and you can pass these batches to your trained model. And again, this is just creating instance of that class, the network you have. So whatever weights you have saved in your disk, you can again load those using this function. All right. So these are like the train weights, and then you just do the forward pass, and this output will tell you the prediction from the network. So that's just testing, and you can use like these outputs in whatever way you want to compute accuracy, precision, or whatever you want to do out of that. All right, so that's the complete training process, and so that was on CPU. And if you have to train your model on GPU, all you have to do is you'll have to define your device. Okay, so this function will just figure out like if you have GPUs present in your machine or not. If not, it will fall back to CPUs. If yes, then it will have that information in device, and you just forward your net to that GPU device. Okay, so again, this data is also going to go to device. So whenever you have to send like data from CPU to GPU, so this is another way. And we have seen like another way, like the two tensor function, right? So that is also fine. This is also fine. But you have to make sure like whenever you're training your network, everything should be on GPU. Okay. For data loader, you don't have to worry because your transform. Oh, you're okay. I think my bad. So earlier, I think in the transform function, when it was doing two tensor, it's not actually sending to GPU. It's just converting NumPy arrays to PyTorch tensors. Okay, sorry, that was my bad. So it was just converting. And of course, you can use PyTorch tensors on CPUs as well. And this is actually sending your networks or your data, your variables to GPUs, considering that you found this device here using this API. Okay,